So it's a little bit, it's a converse. If they're telling us the lines are, the angles, corresponding angles are congruent, cut by a transversal, then we can say, well, those two lines must be parallel if those are congruent. So we're going to work with that a little bit today. Explain how the corresponding angles postulate and the corresponding angles converse are different. What would you say for that? How is this one different than the one we learned before? What happens when you make a converse statement? Maeve, what were you going to say? Oh, no, tell me. You don't have to answer that question. Right, you're right. That was the difference, right? So basically, instead of telling us that the lines are parallel, they're telling us that the corresponding angles are congruent. Basically what they're doing is switching the if-then statement, right? Switching the if-then statement. Can't spell. We're told the angles are congruent. Therefore, has anybody ever seen this for therefore? 3 dots. I guess it's like medical shorthand or something. Therefore, the lines are parallel instead of the other way around. Okay, so here we go. You need to write small here. So if 2 lines are cut by a transversal, so the alternate angles are congruent, then the lines are parallel. I don't know what that's there for, I'm not sure. Alternate angles, okay, it's the same thing, alternate angle converse basically. Given that angle 4 and angle 5 are congruent, prove that G is parallel to H using the corresponding angles, okay? So the way we're going to do proofs, we're going to kind of write our reasoning really shorthand, and then we're going to take that and write out in words what we did. So over here on the right side, you will often see what's called a two-column proof. And you can just do that real quick here if you want. So let's look at what were we given here? We were told what? Angle 4 is congruent to angle 5. We were given that. So I'm just going to write that down. That's always the first thing you write, the given. Angle 4 is congruent to angle 5. Now let's look at that picture. What else can we say from those pictures? What else can we say here? We can say, somebody said it, what? We can't say that yet. We can say that eventually, but how do we get there? We don't know they're parallel. We have to prove they're parallel. What other thing do we know for sure? There's 2 more angles we know for sure are congruent in here. Yes, Will. We don't know that yet. We're getting there. We have to get there. Yes. Which 2 angles? There's another number here that we haven't used. Well, what do you think? Why can we say that? Why can we say that? What kind of angles are they? Yeah, Chloe. Vertical. So we can say that angle 4 is congruent to angle 1 because they're vertical angles. So I'm just going to write vertical. Vertical angle theorem, we would say. Okay, but we'll just write that's our reason for now. All right. So therefore, let's look what we have here. Can we now say something about 1 and 5? Because of what we wrote here. Look at this. What can we say about... Oh, I heard it. These things right up here, right? A equals B, B equals C, then A equals C. Well, look at this. 4 and 5 are congruent. 4 and 1 are congruent. So we can say what? 1 and 5 are congruent, which is going to help us. Angle 1 is congruent to angle 5 because of the what property? Transitive. So now we're closer. We're closer to being able to say that the lines are parallel. How come? Can we do it now? Can we say the lines are parallel? We can. We can because of these. These are what angles here? What are they called? Yeah, because of the corresponding angle converse, we can say that they're parallel. If we prove that the corresponding angles are congruent, then we can say that these lines are parallel. Okay? So, corresponding angle converse. All right, now that we've got our rough draft, we're going to write it out in sentences, like bullet points. So, that's what I want to do right here. So you can number it, or you can just use bullet points. I want you to write this in sentences, okay? Corresponding angle converse, okay? So I want you to take and write each of these things that you wrote here out in words. Yep, and that's how you're going to be writing proofs now. So let's take a second to do that. Yeah, not so bad. Practice. Practice, practice, practice. So we get to do another one. Well, actually, I don't even think we got another one on here. Let's turn it over and see what's on here. So this is kind of an example of what you're going to have to do in your homework a little bit. Turn it over. All right. Is there enough information in the diagram to conclude that M is parallel to N? So this isn't even writing a proof. It's just kind of making a decision whether there's enough information. What do you think? Why? Tell me why you say that. What do you think, Will?
Well, like, you can fill out technically all the angles because, you know, that 75 and the vertical angle we use right? Yeah.
And what's this one right here?
105. Wait, no.
This angle right here?
75.
75. Let's just stop there because we're talking about the corresponding angle converse here. So, do we have enough information now? Could we prove this based on what? What Will just said, which is what? Linear pairs, correct? And then congruent corresponding angles, right? And then we could say they're parallel. So, I would say yes, because, that's my abbreviation for because, corresponding angles to the angle measuring 75 degrees also measures 75 degrees since it forms a linear pair with a 105 degree angle. So something like that. Didn't know you'd have to write in geometry, huh? Yeah. All right, the next one. Find the value of y that makes A and B parallel. Well, this shouldn't be too bad. What kind of angles are these? Yes, and if we're trying to find if A is parallel to B, these two have to be what? Congruent, right? So, I'm checking that because of the alternate exterior angle congruence, all right? Actually, we're just finding y. We're not checking it, sorry. So subtract 6. And y equals 23 degrees. So we really didn't have to do much with that. That is what I would plug into here to get a value of 121, making my alternate exterior angles congruent. And then I can use the converse. All of those that we learned, there's converse for it. If you can prove they're congruent, then you can prove the lines are parallel. If you can prove the angles are congruent, then you can prove the lines are parallel. Here's the transitive property written out right here. Oh no, this is slightly different. Theorem 3.7. Transitive property of parallel lines. If two lines are parallel to the same side line, then they are parallel to each other. So I'm going to draw a picture here. A, B, and C. So I'm going to say, okay, A and B are parallel. And I'm going to say B and C are parallel. Sometimes you'll see two arrows like that because they're talking about different lines. Then I can say line A is parallel to line C because of the transitive property, which makes sense, okay? All right, can you prove that lines A and B are parallel? Explain why or why not. So, can we prove that they're parallel? With the information given here. They're telling me that these angles are congruent. Are they one of these angles? Do they meet the criteria there? Which kind are they? Alternate exterior. Here's my transversal. These are on the outside and they're opposite. So I would say yes because of the alternate exterior converse. If they're congruent, then the lines are parallel. Okay, here. How about that one? Why? Yeah, these are corresponding angles that are congruent, and this is the transversal, therefore these two lines have to be parallel. Yes, because of the corresponding angle converse. Okay, I'm going to stop talking at you, and I want you to think about this one. I want you to think about what would always make it true. Is there a sometimes that would make it true? And is there a never that it's not true? So just think about that one. So no, because we need to know that those two angles are congruent. We don't have enough information. If it had these little things right there, then we could say yes. Cool? All right, let me show you what you get to do. You got some work. You're